Welcome to today's tutorial in the Promise workshop. In today's tutorial we will learn matrices. A matrix is a rectangular array of numbers of variables in rows and columns. We have an example here, and this is what we call matrix, and the number of rows and columns defines the matrix. That means row times column. This is the row, the numbers here, the variables here are the rows. This is another row, this is another row. So that is the role of a matrix. This is a column, this is a column. That is the column of a matrix. We said the number of rows and columns defines the matrix. Like now we have this matrix here, we have 3 rows here, we have 3 rows and 3 columns. So this is a 3 by 3 matrix, a 3 by 3 matrix. For B we have 3 rows, row 1, we have 3 rows and 2 columns, and this is what a 3 by 2 matrix, 3 by 2 matrix. Transpose of matrix, that means A subscript T, is a conversion of the rows of A to columns and the columns of A to rows. So we are told to transpose a matrix. It is just the conversion of the rows of that matrix to column and the column of that matrix to row. Example, given A equals to this, we want to find A transpose, the transpose of this matrix. Like I said, it's just the conversion of rows to column. So to do that, this is the column here, we have column 147. To transpose that, it will be 1 4 7, and this is 258, and that is 2 5 8, and lastly we have 3 6 9. So this will be 3 6 9. So this is the transpose of this matrix. You can see we convert the column into rows, and likewise we convert the rows into column. So this is how to find the transpose of a matrix. Addition and subtraction of matrices. Example 1, we have 2 matrices here. To add or subtract 2 matrices together, number 1, the 2 matrices must be of the same dimension. That means they must have the same dimension. This is a 3 by 3 matrix, this is also a 3 by 3 matrix, so addition and subtraction is possible. It is impossible to add a 3 by 3 matrix with a 2 by 3 matrix. So we have an example here. We have to find A plus B. We have A plus B. So to add these 2 matrices together, each element will be added to the corresponding element. The element in this A will be added to its corresponding element in B. That is 2 plus 1, 6 plus 6, we have 1 plus 5, we have 3 plus 4. We have 5 plus 7. We have 1 plus 1. We have 1 plus 2. We have 3 plus 3. And lastly we have 8 plus 4. So therefore we have a plus b equals to, we have 3, 12, 6, 7, 12, 2, 3, 6, 12. So this is the addition of matrix A and matrix B. Example 2, we have to find A minus B. We are given two matrices, we have to find A minus B. We have A minus B, and that equals to, so we have 2 minus 1, 6 minus 6, 1 minus 5, we have 3 minus 4, we have 5 minus 7, we have 1 plus 1, we have 1 minus 2, we have 3 minus 3, and lastly we have 8 minus 4. We have A minus B equals to, so we have the results. We have 1, we have 0, we have minus 4, we have minus 1, we have minus 2, we have 2, we have minus 1, we have 0, we have 4. Please, I made a correction here. The number here is minus 1, not 1. So the addition is still 1 minus 1. And finally we have what, 0 here. So this is how to add and subtract matrices in economics. Scalar multiplication. In matrix, a simple number such as minus 4, 6, 0.8 is called a scalar, and it is denoted with K. To multiply a matrix by a scalar involves multiplication of all elements by the number or scalar. So whenever we are to multiply a matrix by a scalar, it involves multiplying all the elements by what? By the scalar. We have an example here. We have to find Ka. Solution. So we have an example here. To do that, we have 8 multiplied by 2. The next will be what? 8 multiplied by 1. The next will be 8 multiplied by 4. This will be 8 multiplied by minus 9. This is 8 multiplied by 0. We have 8 multiplied by 2. We have 8 multiplied by 7. We have 8 multiplied by 1. Lastly, we have 8 multiplied by minus 6. So we have our results: 16, this is 8, this is 24, This will give us minus 72. This is 0. This is 16. This is 56. This is 8. And this is minus 48. Anytime we are multiplying a matrix by a scalar, the dimension of the matrix does not change. Like what we have here, we have a 3 by 3 matrix. You can see our end result is also what, a 3 by 3 matrix. So this is how to multiply a matrix by a scalar. Multiplication of matrix. To multiply two matrices require that the number of columns in one must equal to number of rows of the other. That is conformability. So in order to multiply two matrices together, the number of columns in the first matrix must equal to the number of rows in the second matrix. We have two columns here and we have two rows here. So conformability is sure here. Another way to test for conformability is to by equating the set of the dimensions together. This is a 3 by 2 matrix. We have 3 by 2 matrix here, and this is a 2 by 3 matrix. If the end digit here of each set, the end digit of this first set and the first digit of this first set are equal, it means the two matrices are conformable, and we can multiply them together. Another thing we should also know about this is that anytime we are multiplying a 3 by 2 matrix by a 2 by 3 matrix, circle this end digit. We are left with 3 here, and we are left with what, 3 in this case. So since we are left with 3, the end result will be what, 3 by 3 matrix. So if we multiply this matrix by this, we are going to have what, a 3 by 3 matrix. So that's another thing to know. The product of AB is the sum of each element of the rows in the first matrix multiplied by each column in the second matrix. That is, we are going to multiply this row multiplied by this and sum them together, meaning we have the first one is 1 multiplied by 2, which is this, plus 2 multiplied by 3, that's the first one. This one, row 1 and 2, we multiply this column, then we move on to the next one, 1 and 2, 1 multiplied by 5 plus 2 multiplied by 1. Move to the next row again, that will be 1 multiplied by this, that's 1 multiplied by 1 plus 2 multiplied by 2. Then we move to the next row, which is 4 and 8. This 4 and 8 is going to multiply each of these columns as well. We have 4 multiplied by 2 plus 8 multiplied by 3. Move to the next one, that will be 4 multiplied by 5 plus 8 multiplied by 1. Move to the last one, which is 4 multiplied by 1 plus 8 multiplied by 2. And lastly, the last row, which is 6 and 9, we have 6 multiplied by 2 plus 9 multiplied by 3. We have 6 multiplied by 5 plus 9 multiplied by 1. We have 6 multiplied by 1 plus 9 multiplied by 2. So that's how to find the product of two matrices. Therefore, AB equals to when we evaluate the first one, we have 2 plus 6. Next is 5 plus 2. We have 1 plus 4. We have 8 plus 24. We have 20 plus 8. We have 4 plus 16. We have 12 plus 27. We have 13 plus 9. We have 6 plus 18. So finally we have the product of AB to be 8. First element is 8. We have 7, 5, this is 32, this is 28, this is 20, this is 39, this is 39 as well, and this is 24. So this is how to find the product of two matrices.